All right, let's talk about Grafana Loki and its query language LogQL. The whole point of this explainer is to give you the practical tools you need to hunt down bugs way faster than you ever thought possible. Let's get right into it.
You know the feeling, right? An alert goes off, something's broken, and suddenly you're drowning in a sea of logs. You're desperately trying to find that one single error message that's buried in terabytes of data. It's slow, it's incredibly stressful, and you know that every single second counts when you're in the middle of an incident.
So why is this so unbelievably hard sometimes? Well, the problem with a lot of the older traditional logging systems is that they work by indexing the full text of every single log line. As your system grows and just pumps out more data, that full text index becomes absolutely massive. That means it gets crazy expensive and slows to a crawl right when you need speed the most.
But this is where Loki just completely flips the script. It takes a fundamentally different approach, one that's actually inspired by Prometheus. It was built from the ground up to solve this exact problem of scale and cost. Let's see how it does it.
Here it is, the big paradigm shift. Traditional systems index the chaotic content of your logs. Loki, on the other hand, only indexes a tiny set of metadata that it calls labels. Just think of them as simple, high-level tags. And because that index of tags is so small and targeted, Loki stays blazingly fast and way more cost-effective.
So how does Loki pull this off? Well, it all comes down to this one key idea, the log stream. A log stream is really just a group of logs that all share the exact same set of labels. So, for instance, every log coming from your production API service, that's one stream. This is the absolute bedrock of how Loki organizes everything.
And that brings us to probably the most important thing you need to remember to get Loki right. You have to choose your labels wisely. You want labels that are static and don't have a million different possible values, what we call low cardinality. Think app, environment, region. What you should never do is use a label for something with super high cardinality, like a user ID or a trace ID. If you do that, you'll create millions of tiny little streams, and you basically destroy the very thing that makes Loki so fast.
Okay, enough theory. Let's get our hands dirty and actually write our first query using LogQL, Loki's query language. I promise you it is much, much simpler than it looks.
So every single LogQL query is going to start with this, a log stream selector. It's always inside these curly braces, and it's how you tell Loki where to even start looking for logs. This selector right here is just telling Loki, hey, I only care about logs that have the label app with the value my service. That's it.
Okay, so after you've told Loki where to look, you need to tell it what to look for, and that's where a log pipeline comes in. The most common one you'll use is a simple line filter. This operator, I ==, just means the line contains this string. So, I == error is like running a massive distributed search for the word error across all the logs you just selected.
And when you put it all together, you get your first complete query. See how it works. The selector in the curly braces finds all the logs from my service. Then, the pipeline filters those lines down to only the ones that have error in them. It's a two-step process. Select, then filter. Simple, powerful, and incredibly fast.
All right. Let's put this new superpower to the test with a real-world scenario. You get an alert. An API is throwing 500 errors. The clock is ticking. Let's walk through the exact steps you'd take to find the root cause. Go.
So here's our game plan. Step 1, we're going to isolate just the logs from the service that's on fire. Step 2, we'll zero in on the specific error messages we're looking for. If we need more context, we can always expand the time range. And for the final step, we'll use a neat little trick to filter out all the distracting noise.
We start with what we know. The billing API in the prod environment is the culprit. So, we punch in this selector. Just like that, we've cut through terabytes of logs from the entire company and are looking only at the one service that matters right now.
Okay, now we tighten the net. We're looking for those HTTP 500 errors, right? And thankfully, our logs are nicely structured, with status code equals 500. So we just add our IL operator to find every single log line that contains that exact string. We are getting so much closer.
Okay, we've got results, but wait a second. They're cluttered with 500 errors from our own internal health checks. These aren't real user issues. This is where you look like a total pro. We bring in the does not contain operator, @=. By just adding @=, health check, we vaporize all that noise and boom, there they are. The real, legitimate errors that are affecting our users.
See, with just a couple of simple operators, you can go from total chaos to perfect clarity in just a few seconds. To make sure all this sticks with you, let's wrap things up with a handy little cheat sheet.
All right, this is your key takeaway. Go ahead and screenshot this, print it out, stick it on your monitor. For labels, you've got equals and not equals. For the actual log lines, you've got contains, does not contain, and for when you need to get really fancy, a regex matcher. Honestly, these 5 operators will solve 99% of your problems. So, today we've been all about finding the what, the error that already happened. But what if you could predict the when? See, LogQL is actually powerful enough to calculate metrics directly from your logs. That lets you track things like error rates over time and even set up alerts. And that's a powerful next step, moving from just reacting to problems to actually predicting them. Thanks for joining me.